Hello everyone, this video is about precise definition of a limit, and it's actually one of the questions on your homework. This is chapter 2.5 question 3. So the question is asking what value we need to pick for delta so that our y value would stay in within 0.2 to the left and to the right of the original value. So if you remember from class, this would be our epsilon value. And if you come right over here, and I'm zooming in because it's a little bit hard to see it on the screen itself. So we're starting at 3, and if you think about it, in class we discussed a size of a part that goes into the car, and if it's a little bit less, a little bit smaller or a little bit bigger, it may not work and create some problems. So for this particular question, our bounds where we can have the part or anything else working properly would be if the size is 3, which is right in the middle, would be the perfect size. But then again, we can get away with anything that is between 2.8 and 3.2, and this deviation away over here is what we call our epsilon. So we have one that is less, that we can go smaller in size, and one over here that we go bigger in size. Let me just change my pen. I think this is too thick for that part, and I'll change it back. So this over here is our epsilon for the lower values, and this over here is our epsilon for the bigger values. So how can we find out? We want to stay within these borders on the left, on the top and the bottom. What can we choose to be the value here or the value here? How far away we need to go on both sides so we can still be in the correct value for the part. And this is where delta comes in. So we can go the most delta away. And let's find out how we can calculate that distance. So we'll start here with that function right here, and we'll solve it and find out what are the bounds for x. So to solve inequality that has absolute value, we can just write it as negative 0.2 is less than, we take the absolute value away, square root of x minus 3 is less or equal to 0.2. And now, how do we solve this? We can work only that part first and this part second, but I'm just gonna work through the whole thing, and I'll just show you what I'm doing to both sides. So if we add 3 everywhere, I'll just change the color so you can see it. So we are adding 3 to this part. Is less or equal to square root of x minus 3. Then again, we are adding 3. And the sign of the inequality changes, does not change just because we are adding a positive number. And again, I'm just going to keep writing right here for the 0.2. And we are adding 3 to this one as well. So if we solve those inequalities, we will get 2.8 is less than x squared is less than 3.2, which are our bounds right here. So 2.8 is our lower bound, and 3.2 is the upper bound that we need to stay in between. So let's find out now what is the value of x in this case. So if we continue working on the equation that we have right now, what we can do is just take all the elements and raise them to power 2. So I'll just use again another color so you can see it. So we have 2.8 right now, and we raise it to the second power. Is going to be less or equal to square root of x raised to the second power, and again less or equal to 3.2 also raised to the second power. And if we solve all of those, 2.8 squared is 7.84 less or equal to square root and power 2 would cancel each other out, so we'll just have x, and 3.2 squared is 10.32. So basically we found out now where is our x gonna land and what are the values of x that we can have. So right here we would have 7.84, and right here we would have 10.32. So we want to see right now how far away we're on the left and on the right side from 9. And to find that out, we can just do a simple calculation. So let's go the one that is to the left side, delta 1, and the one that's to the right side, delta 2, and we can just calculate. Delta 1 is 9 minus 7.84, which is 1.16. To calculate the distance delta 2, we can just get the bigger value, 10.32, and subtract 9, and the result will be 2.16. So which one of those two deltas will work in our case? We always need to choose the smaller number, and I'll tell you why. So if we are 1.16 away, we'll end up right here. If we are 1.16 away on the right side, we'll still be in this interval. However, if we pick up the bigger value, 2.16, if we subtract 2.16 from 9, we'll get out of the value that we're looking for. We'll be still inside on the region that we're looking for right here, but we'll get outside the region if we pick up the bigger value. That's why the result for delta is delta 1, the smallest of the two, and it will be 1.16, and this is our answer. Let me know if you have any questions. I hope that this was helpful. Thank you.